Hello and welcome to the YouTube channel The Intellect Zone. So this is the third video, or rather the third chapter of our O-Level Computer Science lecture series. In order to get a better understanding about our O-Level Computer Science lecture series, make sure to go and watch the O-Level Computer Science introduction video that we have uploaded in our YouTube channel. So without any more further delays, let's hop into the third chapter. The third chapter is named Logic Gates. As the name suggests, here we will be going through the types of logic gates, and after going through them all, we will be going through logic circuits. There are 6 logic gates in number. The NOT gate, the AND gate, the OR gate, the NAND gate, the NOR gate, and finally the XOR gate. Let us start off with the NOT gate. The diagram below the title is the structure of a NOT gate. You have inputs at the back, and one output in front. Basically what happens in this logic gate is that the output is the exact opposite of the input. This is clearly pointed out in this table. If the input is 0, then the output is 1. If the input is 1, then the output is 0. It is as simple as that. Now let's go through the AND gate. The diagram below this title presents the structure of an AND gate. You have 2 inputs at the back and 1 output in front. The AND gate performs multiplication. This is pointed out in this table. If the 2 inputs are 0 and 1, then the output is 0. If the inputs are 0 and 0, then the output is also 0. If the inputs are 1 and 1, then the output is also 1. Well, this is the basic structure and function of an AND gate. The next logic gate is the OR gate. The diagram below this title presents the OR gate. Similar to all the other logic gates, here also we have 2 inputs and 1 output. The OR gate performs addition. This is pointed out in this table. If inputs are 2 zeros, then output is also 0. If the inputs are 2 ones, then the output is also 1. But, if the inputs are 1 and 0, then the output is 1, since addition not multiplication is performed. Let's go now to the next logic gate. The next logic gate is the NAND gate. See the diagram below this title presents the structure of a NAND gate. The logic gate performs multiplication, but outputs the opposite value. For example, if the 2 inputs are 1 and 0, then the output must 0. But since this is the NAND gate, we have to provide the opposite result after the multiplication process. The table which is next to the NAND gate clearly points out the function of the NAND gate. The NOR gate is the next logic gate. The diagram below this title presents the structure of a NOR gate. The logic gate performs addition, but outputs the opposite value. This is similar to the NAND gate. The only difference is that NAND gate performs multiplication, and the OR gate performs addition. To get a better idea, go through the table next to this subtopic. Always remember that the NOR gate performs addition, but outputs the opposite value. Off we go to the last but not the least chapter, the XOR gate. The diagram below this title presents the structure of an XOR gate. Here what happens is that, if you get like terms, you get the output as 0. But, if you get unlike terms, then you get the output as 1. This process is clearly pointed out in this table. If you get 2 ones or 2 zeros, the output is always 0. But if you get the input as 1 and 0, then the output is always 1. Well, that's a basic understanding about the structure and the function of an XOR gate. Well, all that we went through until now were the 6 logic gates. Now let's talk about logic circuits. Simply, a logic circuit is a combination of logic gates that act together to obtain a specific number of correct outputs. For example, in this diagram we can see the NAND, AND, NOR, and OR gates performing together to obtain the output X. Now let's talk about how logic circuits are drawn according to the instructions given. So in this example, they are indicating that the inputs A and B are connected to a NAND gate, which combines its output as an input to the NOR gate. Also we can see that the B and C inputs are connected to a AND gate, which combines with the NOR gate as the other input. At last, the NOR gate output combines with a C input and gets connected to an OR gate, which finally outputs the required value x. Well, this is a basic idea on how to draw a logic circuit. In order to obtain a better idea about this chapter, make sure to go through past papers that contain these type of questions. Also in advance, if you are searching for a website to download notes for various O-level and A-level subjects, make sure to check out our official website. The link is there down below. Well, that's it for this video. Thanks for watching. And as always, stay tuned and enjoy your presence in this intellectual zone.